Good day, and thank you for attending another installment in HORIBA's webinar series. My name is Lance Cizik. I'm the Western Regional Sales Manager. Myself, along with Mick Dolenmayer, the Eastern Regional Sales Manager, and Norio Kobayashi, our product specialist. We are your North American sales team for HORIBA products in the Process and Environmental Division. Our discussion today is going to be over the MEXA-1170, which is our total hydrocarbon monitor. A few things before we get started here is I want to make everyone aware that we are on social media, specifically YouTube. You can go to YouTube, search for HORIBA Process and Environmental, subscribe to our channel, and you'll be able to access all of our past webinars as well as some other information that's on there. We are also on all the other social media platforms, Instagram, Twitter, Facebook, and LinkedIn. So we ask that you please find us, that you like us, that you follow us. If you have any comments, please do make those. That's the way that we can improve our content, is by your suggestions. So please go check those out. A few things today that I'll be covering, our agenda here. I'm going to talk briefly about who is HORIBA. I'll talk a bit about the Houston facility. I'll talk a bit more about our products, very, very vaguely, and then I will pass it over to Norio, and he will speak more in detail about the MEXA-1170. After that, we will have the question and answer session. So who is HORIBA? We were founded back in 1953. We're currently headquartered in Kyoto, Japan, and our directive has always been for the sale of analysis and measurement technology. Since 1953, we've grown to about 7,200 employees working out of 49 different locations across the globe. And in 2019, we did just a shade under 1.9 billion. So where does that 1.9 billion come from? There are 5 business segments in HORIBA, the first being automotive test systems, which is probably our most widely known business segment. This is our auto emissions and vehicle test systems. And then second is the process and environmental group, which is obviously ours, where we monitor air quality. There's also water quality in this division as well. And then we also have the medical, the semiconductor, and the scientific. So if you have any questions about any of these segments, please feel free to reach out to us, and we'll make sure that we put you in contact with the right people. So more specifically, here in the Americas, as you can see here, we have a number of facilities. For the process and environmental group, we're more focused on the two, obviously one in Irvine, California, and then we have one in Pasadena, Texas as well. For those of you that don't know, Pasadena is a suburb that is southeast of Houston. Excuse me. So, and it's a facility that we're very proud of. A bit more about that facility. This group was originally formed as Cameron Process back in 1985, and it was purchased by HORIBA in 2012. In 2017, we started construction of this new building, and in 2018, it was opened. It's 100% HORIBA employees. And who are those employees? They involve CAD designers, project managers, electricians, mechanical engineers, and more recently, we have begun to move our manufacturing process from Irvine out to Pasadena. So we're very excited about that. Very excited about making things even more efficient so that we can serve our customers even better. As far as its capabilities, we can obviously do analyzers. We can also do analyzers shelters. So anything from a rack mounted on a wall, or an enclosure mounted on a wall, to a rack, to a full-scale analyzer shelter. Our goal is to provide a total turnkey solution when it comes to our customers and their needs. We offer field service. If you need something fixed, if you need startup, if you need commissioning or ongoing maintenance and support, we can obviously offer that. We have embedded service contract capabilities, where if you've got a number of analyzers and you want ongoing service, then we can certainly coordinate something to have a technician come out at certain times of the month, or they could be on site each and every day. It just depends on what suits you best. And then lastly, we have RADA testing, which we can also do out of the Pasadena office. And the capabilities and the capacity, it's about a 30,000 square foot shelter, warehouse that we have there. So what does that translate to? It's about 22 shelters, each being about 10 by 20 by 9 in a climate controlled environment. And then we have space for 8 more in an outdoor covered testing area. So plenty of room. As far as the capabilities, we can do sample conditioning system construction, rack construction. We can integrate our own analyzers, obviously, but we also pride ourselves in the ability to integrate non-HORIBA analyzers onto our platforms. So if you have a GC, if you have a turbidity meter, a pH meter, a mass spec, anything like that, not only do we have the capability to do it, but we have the experience to do it. So if you, you don't have to buy the analyzer from us. Obviously, we would certainly like that. But if you do want to shelter, we ask that you please reach out to us. We'll be happy to help. And then again, we have process, electrical, and mechanical integration. Some of the best tube benders in the business. So we're very proud of the work that we do out of that facility. A brief touch on the products here, and as you'll see, or if you've been part of our webinar series in the past, we've had webinar presentations on each of these products. So the trace gas analyzers, the GA, the multi-gas analyzer, the VA, the PG300, which is our portable unit. We have our ambient air monitor, the AP370. And then we have our flagship product, the MEXA-1170, our CEMS unit. As I mentioned today, we're going to be introducing the MEXA-1170, which is a total hydrocarbon analyzer. So without further ado, I will pass it over to Norio.
Thank you, Lance. Hi, my name is Norio Kobayashi. I am a product specialist of HORIBA. Here is today's contents: introduce type of total hydrocarbon analysis, and explain how FID analysis works. HORIBA has two types of total hydrocarbon analyzers, so I will show you both of type. Main part of this presentation explain detailed heated type total hydrocarbon analyzer. Then we cover the capability with specifications and the configurations. Then we touch the maintenance area. Finally, I will go with a couple of applications. At last, explain that non-heated type total hydrocarbon analyzer for your reference. Total hydrocarbon is monitored for many reasons. One of the reasons is related to the environmental, because hydrocarbons form the main components of volatile organic compounds, which is VOC, and industrial emissions, and are classed as harmful to the environmental or human health. The other reason would be a process control for the product quality. Then you talk about the measurement of hydrocarbons. There are mainly two ways. One is GCFID and the other is FID. GCFID is widely used for speciation of hydrocarbons. By using column, you can identify what hydrocarbons are in the sample and how much each concentrations. Because of this column process, GCFID has cycle time to complete the measurement. Normal FID does not have that column process, so the sample is fed into the detector directly. This makes much simple configuration in the system and give a fast response. However, because of this less column, you cannot make speciation. So it depends on the purpose. You can choose right method for the FID. Today, we are going to focus on the regular FID and the HORIBA analyzer model MEXA-1170HFID. This slide shows how the flame ionization detection works. Sample gas is introduced from a sample inlet and burned in a hydrogen flame at the end of the jet nozzle. During this process, hydrocarbons are ionized in the hydrogen flame. Two opposing electrodes are located within the flame. Between them, a direct current is generated and it is proportional to the number of carbon atoms in the hydrocarbon sample. This current is converted to a voltage drop across a high resistance to provide the measurement of hydrocarbon contained in the sample gas. This method provides a total hydrocarbon result as if all carbon atoms are from aliphatic aromatic, olefinic, or acetylenic compounds, where the detector response caused by these atoms are approximately relative to the numbers of carbon atoms present in a molecule. Other types of molecules, including those containing oxygen or chlorine atoms, will respond differently, usually much lower than the corresponding aliphatic hydrocarbon. Therefore, other methods must be determined the exact constituents of the total hydrocarbon response determined by this method. Anyway, FID is good to see the trend of total hydrocarbon, and if you want to see each component precisely, then a GCFID will be another method to achieve that result. HORIBA offers two types of total hydrocarbon analyzers. As the slide shows here, MEXA-1170HFID is for the process gas monitoring. Inside of this analyzer is heated because if your application contains high molecular weight hydrocarbons, you might lose those during the sampling. But by heating all of the sample flow line, you can prevent the loss of those hydrocarbons. Usually, MEXA-1170HFID is used for the process gas monitoring. So as you can see, it covers wide range from 10 ppmC to 200,000 ppmC, and you can set up the 14 ranges within this wide range. We have other analyzer which is non-heated, model APHA-370. This was developed for ambient monitoring, which does not measure hydrocarbon contains high molecular weight hydrocarbons, so it doesn't have to be heated. APHA-370 focus more lower concentrations. Okay, let me talk about the MEXA-1170HFID. The MEXA-HFID is a single component measurement system that measures total hydrocarbon with a heated flame ionization detector. With a sampler and the control unit cleverly incorporated into its compact case, MEXA-1170HFID is both easy to install and simple to operate. It is suitable for a variety of applications such as continuous real emission monitoring or EPA Method 25A compliant, etc. MEXA-1170HFID uses a hydrogen flame ionization detector in a heated block to prevent the loss of high molecular weight hydrocarbons and to provide long-term stability and reliable performance in the analysis of low trace concentration levels of hydrocarbon contaminants. The sample from its extraction to the analyzer is heated up to 191 degrees C. You can select the fuel from H2 hydrogen 40% helium 60% basis mix or pure hydrogen. It is designed for continuous measurement with high accuracy, sensitivity, and high stability. Here is the flow schematics. From the probe, the sample gas temperature is kept over the 191 degrees C or above. Then it comes into the analyzer box, which is also heated. The sample gas is pulled by built-in sampling pump and regulated the flow into the analyzer block. So you can see there is a purge line, zero gas line, span line, and the fuel line, and purified air line. Here is the specifications. Analysis method is heated flame ionization detection, and the range is as written right here from 10 ppmC and 200,000 ppmC. But just be noted when it used pure hydrogen for its fuel, the range will be narrowed down to the 50 ppmC at the lowest and the 10,000 ppmC at the highest. Still, you can set up the 14 ranges in any cases. RS-232C digital in and out and the analog output is available. The sample heated block is maintained at 113 degrees C or 191 degrees C, depends on the application and the target hydrocarbons. This is a system configuration. Just want to touch what the utility we use. Span calibration is done by propane and the 0 is by nitrogen. As you can see, fuel gas has options from hydrogen, helium base or pure hydrogen. As MEXA-1170HFID is 19-inch rack size, you can mount on a rack like the picture shown here. We can customize it according to the situation or requirements. Consideration includes heating bundle tubing controller, and a cabinet for indoor or outdoor use. Also set up to work with the other analyzers such as like a CO analyzers or NOx analyzers, stuff like that. For more complicated application, HORIBA can build a sample system. Of course, we offer you a startup training and field service support as a total turnkey solution package. This page is showing some maintenance information. I'm showing right now a daily inspection item. Basically, replacement sample filter element is the one you normally need to replace. This is the sample filter as a consumable parts. Replacement of the pump diagram and the lead valve need to be replaced every 6 months, and the pump to be replaced every 6 years. And other than that, the O-ring and analyzer adjustment need to be done annually. Okay, let's talk about the application. CEMS, which is Continuous Emission Monitoring System. Continuous Emission Monitoring System is required by US EPA. CEMS is the total equipment necessary for the determination of a gas or particulate matter concentration or emission rate using pollutant analyzer measurements and the conversion equation, graph or computer program to produce results in units of the applicable emission limitation or standard. That's the definition from US EPA for the CEMS. CEMS requires to measure the emission gas from the plant for keeping compliance. So it measures the gas for 24/7. All of the CEMS users have air permit which describe the requirements, what to measure, such as NOx, SO2, CO, O2, moisture, flow, temperature, etc. Then some of CEMS requirements include the total hydrocarbons. So for that purpose, MEXA-1170HFID can be used. By the way, HORIBA has the MEXA-7000 series, which was developed to dedicate CEMS application. We can install MEXA-1170HFID into this rack to work with MEXA-7000, so that you can combine all of measurement data to output together. Typical measurement components for the MEXA-7000 is NOx, CO2, and CO2, SO2, and ammonia. All of 6 components can be measured by this one unit, and you can add the total hydrocarbon analyzer and using the MEXA-1170HFID. And also we can use any third-party product such as flow, opacity, and moisture. So if you have any project for the CEMS install or upgrade your CEMS, please feel free to reach out to us. US EPA defines the measurement method for the total hydrocarbons by flame ionization detection. The number of the standard method is 25A. Basically, this is applied for the continuous measurement. Let me review what the requirements are. Sensitivity has to be within 2% of span. All sampling components leading to the analyzer shall be heated, which is above of 110 degrees C, which is 220 degree F. The FID block shall be heated above of the 120 degrees C, which is 250 degree F. Carrier gas should be a propane in air or propane in nitrogen. The fuel is the hydrogen 40% and the 60% helium base or nitrogen is recommended. And drift within the plus minus 3%, and calibration drift is plus minus 3% of full scale, and the calibration error is plus minus 5% of the calibration gas value. Okay, let's talk about the other applications. This is the catalytic converter. When you have unburned hydrocarbons in your process, you just cannot release to the air. Majority of this application is for car industry. As the fuel is burned to work engine, unburned hydrocarbon will be generated. Catalyst convert works by oxidation, adding oxygen and turns carbon monoxide into the carbon dioxide. There are another oxidation reaction in this catalytic converter, which turns unburned hydrocarbons into the carbon dioxide and the water. By using that data, you can investigate the engine combustion efficiency as well. For the users in the plant, steam boiler for the oil refinery would be another application. Emissions from fuel such as diesel, oil, gasoline, and others produce many more heavier hydrocarbons in the exhaust emission than compared to the compressed natural gas emissions. So it is important that catalyst works properly to convert those hydrocarbons. Since those fuel contains heavy hydrocarbons in the exhaust emission, all of measurement line needs to be heated above 191 degrees C. Hydrocarbon trap is similar to the catalytic converter. Hydrocarbon trap captures the slip hydrocarbons. For the quality check, you measure in and out of total hydrocarbons so that you can ensure the trap is working good. Air separation unit. There are many gas providers in the world. Air separation unit might be in the plant to feed plant utilities such as nitrogen, argon, oxygen. Let me explain the cryogenic air separation process a little bit here. Air is going through the filter and capture the oil of dust in the ambient air. Air is then compressed and going through a molecular sieve process to remove H2O and CO2. Because if the forward process contains those H2S and CO2, then a formation of ice or dry ice may occur in the cooling process. Cold box chills the air at minus 173 degrees C. So before entering cold box, you want to remove H2O and CO2 completely. And the trace hydrocarbon needs to be monitored for the product stream after the distillation process. This is to eliminate the risk of hydrocarbons combining with the liquid oxygen to become an explosive mixture. Ensure quality of the all product streams. Measurement range is 0 to 10 ppm. Carbon dioxide contamination can be a real problem for the sparkling beverage industry. Potential carbon dioxide contamination may include residues in the system, which can be carried over from the feed source from contaminants introduced into the bulk liquid carbon dioxide or from gas cylinders within the distribution. Sparkling beverage manufacturer has concern about some of the compounds, contaminants, as they are known to have a negative impact on the flavor or an appearance of the beverage. Other compounds that are known to be detrimental to consumer safety are governed by regulatory control. Voluntary quality standards are listed in the ISBT quality guidelines, which are shown on the right. Recent improvements with the on-site analytical equipment have revealed that the traditional method of protecting the quality of carbon dioxide, such as passing the gas through an activated carbon bed, cannot protect and maintain the required gas quality. The industry is also becoming increasingly aware of the serious impact of carbon dioxide impurities on the beverage characteristic and the associated consequence of not ensuring its quality. This applies to all sparkling beverage fountain, post-mix, as well as beer dispenser. Okay, now I would like to focus on the low concentration analyzer, APHA-370, which is non-heated type of analyzer. This APHA-370 uses the same measurement method, flame ionization detection. APHA-370 was developed for ambient monitoring. It is applied for low concentration monitoring. Can be used for continuous measurement as well. APHA-370 can measure total hydrocarbons and methane and non-methane hydrocarbons. The range setting is from 5 to 50 ppmC. As you can see, APHA-370 can go very low concentration, and the low detectable limit is 0.022 ppmC. Linearity and repeatability is good as MEXA 1% of full scale. HORIBA has a AP370 series other than APHA-370. Each analyzer has individual measurement parameters. All of model can measure very low concentration. Other than total hydrocarbons, AP series can measure NOx, SO2, CO2, CO, O3, ammonia, and H2S. So let's take a look at this application one more time. As ISBT quality guidelines shows on the right side, there are a couple of the gaseous components. HORIBA AP series can measure those parameters like ammonia, NOx, total hydrocarbons, and H2S and SO2. So I hope this presentation gives you an idea what HORIBA can do with this total hydrocarbon analyzer. And we have many webinar videos posted on the YouTube. Please subscribe us and leave the comment as well. And we keep you updated. Thank you.